Hello, my name is Jessica Talisman, and today we are going to explore information retrieval and the semantic web by looking at DBPEDIA, a knowledge-based ontology that extracts linked open data to information sources online. What is linked data? Well, it's a method of publishing structured data so that it can be interlinked and become more useful through semantic queries, which would be word or normal URL queries. It builds upon standard web technologies such as HTTP, RDF, and URIs, but rather than using them to serve web pages for human readers, it extends them to share information in a way that can be read automatically by computers. Machine-readable linked open data helps to ground data and authenticate data that is published online. Oftentimes, the semantic web will also be referred to as the web of data, which is confusing because semantic refers to words and data refers to information. So when we look at the web of data and the semantic web, there is some question of if the web of data and that terminology is actually an attempt to rebrand the semantic web. The semantic web is more holistic in that it includes the web of data in addition to other elements. Mostly the semantic web is used for information retrieval in finding linked data browsers, linked data search engines, linked data applications, and for web ingest, such as information or data being machine readable, making sure that the code is complete, that the process is efficient and accessible, it is not ambiguous, and that it is multilingual. When we look at the graph, you'll see the web in the center. Communication, address, and identification are all important aspects. On the outer rings, you will see that you have HTML, which is the protocol. That would be the machine-readable language. In this case, HTTP, which would be where it exists online. And the IRI is the linked data. So with all three of those elements, you help to build linked open data online. The semantic web, as termed by Tim Berners-Lee, who's the co-inventor of the semantic web concept, is not a separate web, but an extension of the current one, in which information is given well-defined meaning, better enabling computers and people to work in cooperation. The graph displays very well the building blocks involved with linked data in the semantic web, or the vision for the semantic web. The base, which are the red blocks, show the URI or identifiers, which can be in several different formats, and Unicode, which are character sets. And then on top of that, the syntax, XML, and that's very important because it's machine-readable language. The data interchange happens through RDF, which is also machine-readable, and taxonomies can be built using the same RDF. The querying can happen with both RDF and Sparkle. The ontologies in the original DBPEDIA ontology was based on OWL. And as you see, as we go up through the blocks, at the very top is trust. And above trust is that we supply users with trustworthy interfaces and reliable applications. Part of the semantic web is the cognitive web. It is impossible to take the human out of the computer, as ultimately it is the human who is creating the query or searching online. Cognitive aspects emerge as an essential ingredient for future work on knowledge acquisition, representation, reasoning, and interactions on the semantic web. Visual interfaces have to support semantic-based retrieval and at the same time hide the complexity of the underlying reasoning machinery from the user. Looking more closely, There are 6 areas where cognitive computing must be applied to create noteworthy difference. Those qualities are predicting quality, preventing quality degradations, detecting quality issues, diagnosing and classifying defects, remediating or self-healing, and revalidating. The consumer has to trust the query process and also trust the information that is being returned through queries. More about dbpedia.org. It was founded in 2007, DB standing for database and pedia as in Wikipedia, and it's an effort towards the actualization of the semantic web. The dream? To extract data from the web, which has mainly been from wikis, and validate that information retrieved by attaching authority controls, also known as linked open data. DBpedia's corporate statement is towards a public data infrastructure for a large, multilingual, semantic knowledge graph. One of the goals of DBpedia is to crystallize the web of data, or the data portion of the semantic web. By extracting structured data from Wikipedia and other sources through RDF and Sparkle, you increase interoperability. And interoperability is important so machines can talk to other machines and data can be exchanged. With greater interoperability, you improve applications. With improved applications, research benefits, users benefit, and we have a more trustworthy web environment. DBpedia was founded at Leipzig University in collaboration with the University of Mannheim and OpenLink Software in January of 2007. Its operating system is formally Virtuoso Universal Server, which sometimes works and sometimes doesn't. Its type is considered a semantic web involving linked data or linked open data. One important aspect is there are many cooperating privately held and also publicly traded companies that are involved in the development of DBpedia worldwide and help to fund the project to encourage a more trustworthy semantic internet. The ontology is the base of DBpedia. It was built completely upon one single ontology that continued to extrapolate and extrapolate and extrapolate as more linked data was harvested and connected to the ontology. So you have raw RDF, you have many different vocabularies, metadata, machine readable. You have Sparkle, which is a database-driven search or query process. So it's pretty impressive when you look how all of the different aspects are interlinked. You have geonames, friend of a friend, which is a metadata. And we also have some Library of Congress subject headings, VIAF, which is the Virtual International Authority, and it goes on and on and on. So the ontology is huge, but the one aspect of DBpedia that's unique is it has one single ontology rather than several parallel ontologies, which helps to control the data or the information being ingested. Is DBpedia a knowledge base? Well, of course it is. A knowledge base is a technology used to store complex structured and unstructured information used by a computer system. If you remember earlier, DBpedia was identified in 2007 as only ingesting or harvesting structured data, and now it has the ability to also harvest unstructured information. The initial use of the term was a connection with expert systems, which were the first knowledge-based systems. So one of those initial knowledge-based systems would be wikis. And so using wiki to extract information has been beneficial for both wiki and for DBpedia, because by linking data or authority sources to information, there is a completeness where both knowledge bases benefit and they help to strengthen one another. So I decided to try to find a way, because Virtuoso would not work for me, and that is its dedicated database or search engine. I just went to Google, and by chance, I decided to look at just searching in the bar for DBpedia and maybe how it's connected to informatics. And this was just a curious search. It wasn't anything super formal. And as you can see, there's several results, and with informatics, you can see that the paragraph, the initial paragraph, this has led to the study of and it's not complete, an incomplete sentence. But there is some good information. DBO is the stands for, if you see on the left-hand corner, is the DBpedia ontology. So DBO is DB ontology. It has not only the wiki page ID, but wiki page revisions, which is very important. You have RDF, OWL, friend of a friend. And as you continue down the page, it is extensive. So informatics is very well documented within DBpedia. Looking at other structures, I was curious just to see if another search would populate with the DBpedia knowledge base. And I decided to look at Portland, Oregon, where I live. And indeed, Portland, Oregon did come up, although Portland, Maine also came up. And you also see Oregon Scientific, which is a company, not exactly Portland, Oregon. So there are many sources that connect to DBpedia, and I was fascinated to find that simply Googling DBpedia with what you are looking for, Google as a search engine will pull up the DBpedia specifically for your search or query if it is in their knowledge base or database. So this is an illustration of the current DBpedia data provision architecture. So the Virtuoso Universal Server, which I could not access to search, it kept on defaulting or timing out or saying that it was down at the time. But you can see that because now it does not, DBpedia does not only ingest or extract structured data, it also ingests or extracts unstructured data. And in doing so, it's able to do a URL rewrite, and it deploys services to link data to the unstructured data. And this is mostly through Wikipedias. At the very top, there's HTML browsers, RDF browsers, and Sparkle clients. So you can search through a database search, RDF browsers, so using commands through RDF, and just through a normal search like I did on Google. And ultimately, it all goes back to the same place, which is the deployment service of linked data. So today's knowledge bases are very extensive and cannot be limited. And DBpedia's ontology, one single ontology, is not only open source and a knowledge base, but also an ontology. And part of that ontology is taxonomic knowledge, factual knowledge, temporal knowledge, emerging knowledge, and terminological knowledge. So this example is Elvis Presley. And his type is American Singer, and that type might be from RDF or it might be from Dublin Core, which is a metadata standard. Subclass of, again, it could be RDF or it could also be Dublin Core. and it says that he's saying, so that might be from schema.org. Born in, and that is a geolocation, or it could also be from schema.org. And looking through it, you can see that there's an ID 11. So that code is very important in placing Elvis Presley temporally. So the temporal, which is in time, identification is the ID 11. This is the ontology as it appears. And when you go to the DBPEDIA site, it's just simply a list. And if you have a DBPEDIA account, you can actually edit any of the ontologies. Within any given topic, subject, or idea within the ontology, there are going to be multiple different definitions and renditions. For example, a label might exist in 20 or 30 languages. And some of the instances and terminologies may actually be relevant to other cultures other than our own here in the United States. So looking at artist, I did find something somewhat funny, because it shows the extent to which someone or anyone can create linked data. So I found bust, waist, and hip size under artist, and within that, by going to DBPEDIA Live, and this is a beta test right now, this is live extraction. DBPEDIA Live serves to, in real time, extract data from Wikipedia so that the data doesn't sit in silos and eventually become outdated. So it's an attempt to keep it current. And so this property can only be used if all three are achieved, that you have bust, waist, and hip. So DBPEDIA Live, moving on. The core of DBPEDIA, it's info box extraction process. So it's kind of the reverse of a basic retrieval through your search engine or browser. So there's an extraction process, and the example of Wikipedia is it uses Open Archive's initiative protocol, which is OAI. And that's a metadata harvesting application. So you get a continuous stream of updates from a wiki. And so once that protocol is set up, then it's able to extract the information, and it's either already connected to open link data, or DBPEDIA will connect it to open link data, or possibly something that already exists, build upon something that already exists within DBPEDIA's ontology. So as information retrieval applications, we can see that the data ID core of DBPEDIA is in fact the ontology, which is extensive. And the next ring, which is data ID common extensions, these are highly reusable ontologies, and they adhere to the same principles as that core. So linked data, statistics, activities and plans, and other data ID ontologies all support that data ID core. And then the most outer layer is use case extension. So it's importing data ID core and any number of common extensions. So it might be an extension to the wiki page, and it's the wiki page identification, for example, and then the revised or updated wiki page. So DBPEDIA's effort really is to deliver reliable data sources using linked open data. This is the architecture of concept-driven information extraction and entity linking. So if we look from the top, you have articles and you have concepts. So we have, for example, if it's a corpus model, we're looking at web scraper, pre-processing module, and stop word removal. So those items need to be established in order to do a clean extraction process without grabbing unnecessary information. And the concepts collection module is based upon DBPEDIA ontology, which, as we know, is extensive, Sparkle, which is the database search and retrieve, and persons. People are involved ultimately. And it's important that entity mentions extraction happens, entity mentions URI mapper, which URI is a permalink, and sentence extractor, and triples, which is also known as RDF extractor. So it's like person, place, thing, that it is like a complete sentence or a complete concept. The information extraction is defined as the task of extracting raw text from natural language-based documents. So natural language is language that we use, not machine language, but actual words. And the IE, or information extraction systems, are responsible for processing text from input documents to separate useful raw text from noisy and irrelevant text. By eliminating irrelevant pieces of words or phrases in an attempt to establish further meaning of extracted terms as entities and associate relevant relationships among them. Creating relationships is one of the most important aspects of linked data, and that's how we connect and create and build the semantic web, so that linked data can be connected to other linked data, can be connected to other linked data, and that helps to build a stronger and more reliable housing for information. So when we look at the outcome, we have textual data that can either be used directly for the purpose of presenting it to the user or someone who may be searching for information, or it can be stored for further database-oriented tasks such as cleaning up or remediating something within the DBPEDIA ontology. It can be used for natural language processing or information retrieval tasks and applications. And truly for applications to make them more reliable, especially an example like Wikipedia, authenticating and grounding that information with linked data helps and has helped Wikipedia to be more respected and more reliable as an information source. So DBPEDIA can act as a data solution, with DBPEDIA extracting structured and unstructured data, which is newer, is the unstructured data part, the natural language process, NLP, and the implementation of cognitive web tools are necessary to round out the visions for the semantic web. So we have our query, and there is a repository of information, and our query will draw from that repository of information. They act like brokers. And so ultimately, we're looking to discover knowledge. By using the ontological-based schema approach, it helps to transform textual data into ontological-based schema. There's a quality assessment that occurs, and then the quality control happens. So ultimately, the repository and the ontology is built by assigning linked open data protocols, authenticating the knowledge, quality control, so checkboxing that yes, this is quality and verifiable information, and then returning that knowledge or that information back to the user. So what is the future of DBPEDIA and information retrieval? I really liked this comparison that was used from an article by Leonard that was written in 2015, and I think it's applicable today. When we look at the semantic web is not only a web of data, but it also involves cognitive computing, or the cognitive web, neural networking, which has to do also with machine reading, AI, and how we can connect the human aspect with the machine readable or computing aspect. So the semantic web, to be realized wholly and truly, has to be a balance, a continuous and evolving balance between algorithms and human rhythms. So explicit verifiable data feeds might come from algorithms, but humans might have unsaid, implicit, assumed things. An algorithm might track and save everything, while human rhythms engage only with what matters to each individual person. An algorithm is an intelligent cloud or machines, while humana rhythms create irrational humans. They're creative, irrational humans, and less predictable. Algorithms are fact and data driven, which is a perfect example of how DBPedia works, while humor rhythms are holistic and fuzzy in that they're complete people, and that sometimes they have emotions that can be sad, happy, angry, and those have to be taken into consideration when we look at the semantic web. Finally, algorithms are part of information knowledge economy. So there is an economy that is built around these algorithms to retrieve data in linked open data being connected to information in the semantic web, as DBPedia has done. Humor rhythms have experience or wisdom economy, which means that trends, personal choices, personal knowledge bases, and personal experiences become an economy unto themselves, and they can affect the algorithms. So the human and the machine cannot be separate. For the future of DBPedia and information retrieval, neural networking, cognitive computing, and testing human query relevance further than what has already been tested will be necessary to improve the wonderful concept of DBPedia and its ontology, and retrieving linked open data to ground information and knowledge, creating an even larger authenticated semantic web as imagined.